Hi everybody, welcome to our first online learning day. If you have a printer at home, you are welcome to print out the notes and follow along with me. If you don't have a printer, you can take some notes on a separate sheet of paper. So what we're going to be talking about today is the difference between quadratic functions and exponential functions. Exponential functions we did talk about in class. So we talked about how in the y values, there is not a pattern of addition or subtraction. There are patterns of multiplication or division. So in this table, in the y's, we have a pattern of multiplication. Also with exponential functions, you're going to have a number base and a variable exponent. So like 2 to the x or 3 to the x. And it has a curved graph. For quadratic functions, their graph is more U-shaped. This is called a parabola. The function is going to have a variable base and a number exponent. So the number is going to be the exponent, but the base is going to be a variable. Here it's the reverse. The base is a number, the exponent is a variable. And in the quadratic, there's not going to be a pattern of multiplication or division in the y's. So there's no number we could multiply 0 by to get 1. 0 times anything would be 0. There are, though, going to be patterns of addition or subtraction. It's just that we're going to have to add or subtract 2 times in order to find a pattern. So if I try to find a pattern of addition, so from 0 to 1, 1 to 4, 4 to 9, I have to add 1, then add 3, and then add 5, which isn't a pattern because they're all different numbers. 1, 5, 3, not the same numbers. But there is a pattern within the 1, 3, and the 5, and it is that to get from 1 to 3, we're adding 2. To get from 3 to 5, we're adding 2. So this is called a pattern in the second difference. So if there's a pattern in the second differences, this is going to be a quadratic function. So down below I have a bunch of tables, some examples here that we're going to take a look at and decide whether they are linear, exponential, or quadratic. So if we take a look at the y's in the first table, we go from 5 to 20, from 20 to 80, from 80 to 320. So we want to see if there's a pattern of addition or subtraction. So to get from 5 to 20, we could add 15, and then we would have to go from 20 to 80, we'd have to add 60. So it's definitely not going to be linear, but we are able to find a pattern of multiplication. So if we're able to find a single pattern in the y's of multiplication, it's going to be an exponential function. If we take a look at the second table, to get from 2 to 8, we'd have to multiply by 4. But to get from 8 to 18, there's not a nice integer that we could just multiply to get from 8 to 18. So this one's not going to be exponential. So let's try to start to find patterns of addition or subtraction. So to get from 2 to 8, we would have to add 6. To get from 8 to 18, we would have to add 10. And to get from 18 to 32, we'd have to add 14. So there's not a pattern in the first differences, so it's not linear. But there is a pattern in the second differences. To get from 6 to 10, you have to add 4. To get from 10 to 14, you have to add 4. So since there's a pattern in the second differences, this is going to be a quadratic function. So let's try another example. So to get from 10 to 7, we could subtract 3. To get from 7 to 4, we could subtract 3. To get from 4 to 1, we could subtract 3. So minus 3, minus 3, minus 3. Since there's a pattern in the first difference, this is going to be a linear function. And then example 4, to get from 0 to 4, we have to add 4. Then we have to add 12. Then we have to add 20. So there's not a pattern in the first difference. But there is a pattern in the second. If we add 8 to 4, we get to 12. If we add 8 to 12, we get to 20. So when there's a pattern in that second difference, it means we have a quadratic function.